All right, so this video is about graphing the parent function for the rational functions, okay? It's y equals 1 over x, all right? The rational function sometimes referred to as the reciprocal function, all right? So I've got a pretty good group of x values we're going to plug in for x here and get our y values, or f of x, whatever you want to call it, okay? So when I plug in -8, I obviously get -1/8. And I'm going to put these in decimal form just because we're going to need to be able to look and see as x gets smaller and smaller, or down here as x gets bigger and bigger, what's happening to y. So I'm going to use decimals here instead of fractions. When I plug in -4, I get -1/4. Okay. When I plug in -2, I get -1/2. When I plug in -1, I get -1. And when I plug in -1/2, I get -2. 1 divided by -1/2 is -2, okay? So what's happening to these y values when x is negative? We're going to look at that going, you know, as x gets smaller and smaller and smaller, or as x gets closer and closer and closer to 0, okay? There's going to be a reason we talk about those things, and that'll make more sense a little bit later on, okay? At 0, we get undefined, okay? You can't divide by 0 here. So there's not going to be a coordinate or an ordered pair that has an x value of 0, okay? When we talked about domain earlier in the year, 0 would be excluded from the domain here because it makes the denominator 0 and gives us an undefined value, okay? Now let's plug in some positive values. When I plug in +1/2, I get +2. When I plug in 1, I get 1. When I plug in 2, I get 1/2. When I plug in 4, I get 1/4. And when I plug in 8, I get 1/8, okay? So if we were to plot all these points and kind of continue things the direction they're going, the graph of this parent rational function should look like this, okay? So there's a couple things that happen here that we haven't really talked about in maybe ever. I might have referenced them in class, but if you'll notice here, the graph never crosses the y-axis here, and that's because at x equals 0, we get undefined. So that means the graph can never, ever, ever touch the y-axis here, okay? And because of that, this is going to be referred to as a vertical asymptote. And I'm going to show you a little bit later what that means and how to find it, okay? There's another thing that happens here. As x gets smaller and smaller and smaller and smaller here, we're going to get closer and closer and closer to the x-axis. But notice, I can never get 0 here. 1 divided by a number, no matter how big it may be, okay, no matter how great the magnitude is, can never be 0, okay? If I plugged in -1 million here, I'm not going to get 0. I'm going to get -0.000001, okay? If I plug in a positive number, like 1 million, again, I'm never going to get 0. I'm going to get really close to 0, but it'll never actually equal 0. So these pieces here and here, they're going to continue indefinitely to the left and the right, respectively, but they're never going to touch the x-axis, okay? That's called a horizontal asymptote, and it's going to tell us what the behavior is as we have a bigger and bigger value magnitude negatively and positively, okay? So those horizontal asymptotes, we'll go over in the next video how to find those, okay? Some notation here that you might not be familiar with, okay? This means as x approaches any value, and I'm going to call it a for now, we're going to call it z in a 0 in a second. As x approaches a from the left, this negative, superscripted negative sign there just means from the left of this number a, okay? If we've got a superscripted positive up there, it's going to be as x approaches a from the right, okay? That matters with the vertical, asymptotes, okay? This symbol, this notation here, as x approaches -infinity, that means as x gets smaller and smaller and smaller and smaller and smaller, it keeps going to the left, okay? And this notation means as x approaches +infinity. So as x on the axis here gets bigger and bigger and bigger and bigger, okay? And I've already kind of talked about those a little bit, but we'll talk about them more in just a second, okay? So the vertical asymptote, I've already talked about what that is. The vertical asymptote is going to be the vertical line here at x equals 0, okay? And in the next video, I'll show you how that's calculated, okay? The horizontal asymptote is the horizontal line here at y equals 0. The x-axis has an equation of y equals 0. Again, we'll find out how that's determined in the next video, okay? Now, so what happens to the y values as the graph approaches the vertical asymptote from each side, okay? So what that means is, as we approach x equals 0 from the left, what happens? And as we approach x equals 0 from the right, what happens, okay? So you can look at the graph or you can look at the table of values over here. I'm gonna start with the table. So as we get closer and closer to 0, our y value it's still negative, but it has a greater magnitude, okay? If I plugged in negative 1/10, this would be negative 10, okay? So the magnitude gets larger and larger and larger. We're still going down, okay? So it's gonna go towards negative infinity, okay? So as x approaches 0 from the left, okay, y is going to approach negative infinity, okay? As x approaches 0 from the left, y approaches negative infinity, okay? Now, as x approaches 0 from the right, that means from the right side, we're getting closer and closer to x equals 0. Notice the graph goes up here, okay? And the table, as we get closer and closer to 0, our values get larger, okay? So what that means, as x approaches 0 from the right, that means y is going to approach positive infinity, okay? As x approaches 0 from the left side, y goes down to negative infinity. As x approaches 0 from the right side, y goes up to positive infinity, okay? Last thing here, what happens to the y values as x approaches positive infinity or negative infinity, okay? We'll start with negative infinity. So as x approaches negative infinity, okay, we've got x at negative 1/2, we've got x at negative 1, negative 2, negative 4, and negative 8, okay? As x keeps getting more and more negative, we're going towards negative infinity here, what happens is this y value gets closer and closer to 0, okay? So we say y approaches 0, all right? So the graph approaches the x-axis, y equals 0, as x approaches negative infinity. The same thing happens on the right side. As x approaches positive infinity, this y value is going to approach 0 as well, okay? So on the extremes of each graph, okay, the y value is getting closer and closer to 0. It will never equal 0. It will never cross over the x-axis here, but it approaches 0, okay? So we say the graph approaches the x-axis, or y equals 0, as x approaches positive infinity to the right and negative infinity to the left.